Welcome back to Notes for Engineers. I'm Alistair Cook and I'm joined by Michael Webster. Michael, you've been with me a couple of times on the videos. What have you got for us this time?
So this time what we're going to talk about, Alistair, is upgrading a Nutanix storage platform and how that works and in a web scale environment and what we mean by that.
Don't web scale applications just shut everything down and build from scratch again?
Nah, well, it depends how the application's written, but a lot of the time it's built resiliently, so that if there is any type of failure, it just keeps on going. And that's the way that Nutanix has built the infrastructure, so that if the infrastructure is upgraded or something fails, the applications just keep on running as if nothing's ever happened.
Awesome.
So with the release of Nutanix operating system 4.0, we've got this concept of a one-click upgrade. So it's basically like the the iTunes App Store or the Mac App Store, where you click on the download, or it's automatically downloaded the new upgrade for the entire storage platform. You click it once and it seamlessly upgrades the entire environment.
Just goes and does everything in the background.
Exactly. So what I'm going to draw is a pretty normal 4-node cluster with our 4 hosts, and we've got our Nutanix distributed file system that sits underneath. And this is made up of the local storage on each of these nodes. So on each of the nodes we have a Nutanix controller virtual machine, which is really the storage controller in this environment. So the more nodes you've got, the more controllers you've got. And then we've got our user interface, which also is on each of these because it's a completely distributed system, which means there's no single point of failure. And we have a virtual IP address that bounces around to wherever it's going to live, and you can access the user interface through that. So during an upgrade scenario, basically you'll get an alert in the user interface to say there's a new upgrade available, would you like to apply it? And then during the appropriate time for your organization, you go into the user interface and you click upgrade. Now
so it is like the App Store on my Mac, which says you have 173 updates. No, sorry, that's my Android phone.
That's right. Yeah, it would usually say there's only one upgrade because it'll normally be only one upgrade at a time, unless you've left it a few versions, and there might be a few different versions to choose from. And you can set it to either automatically download the updates, or for you to tell it when to download the updates.
And presumably for an isolated environment, you could manually download the updates and provide those.
Exactly. Yeah, we have a lot of dark environments which are not accessible to the outside world or other connected networks. In which case, you would download through a secure means the update, and there's also an authentication token that checks that it's a valid update and it's it's come from us, not somebody else, and does all of the
tampered with in transit.
Exactly, hasn't been tampered with. And both of those things are required to do the update so that we know that it's a valid update to apply. Now, so once you've clicked this button, basically what it does is it goes through and it checks every single host to make sure the health of the environment is suitable for the upgrade. If the health of the environment isn't suitable for the upgrade, it will stop. So it's not going to do an upgrade if there's a problem existing.
So if there's a latent error that you haven't fixed, if there's a node that's got some hardware fault because the cleaners hit it with a hammer.
Yeah, exactly, something like that. Now, what it will do is, so let's say this is the upgrade cloud up here, and this is our little button. I think that's probably the best way to draw a little button. If I could draw in red, I'd put it in red. And that will go through, and it will upgrade every node in parallel in terms of the software. Now we've got dual boot banks, so like one's active, one's sort of passive, and then after they're all upgraded and we've checked that the upgrade's been applied.
So we overwrite the non-active boot bank with a new version on all of the nodes before we switch?
That's correct, yes.
Good.
And then we check the validity that it's been applied correctly.
So check some kind of behaviors on the image laid down.
Exactly. And then what we'll do is we restart each node at a time. So we'll take that node down, restart that node. When it comes back up, we check that it's
by restart, you just mean the controller virtual machine,
just
not
the
all the
virtual
VMs,
machine.
Not all the hypervisors.
Exactly. So these virtual machines here, they stay on. So there's no issues at all. So what happens? Our storage controller's gone down. Well, it's pretty much like a normal environment. If your storage controller goes down on a storage array, the IOs get redirected to another storage controller.
To another controller.
Exactly. So the IOs from this controller would come from over here. For the period of time that is rebooting. Now, the reboots take about less than a minute. So it's going to be for a very short period of time. And the actual redirection of the IOs is seamless to the virtual machines.
And if this happens in a normal operation failure of a controller virtual machine, there's a 30-second timeout, isn't there, for this failover?
No, with 4.0 we improved it so that even if a controller virtual machine fails, it will usually fail over within 15 seconds or less.
Excellent.
In most cases, it's a lot less because our heartbeats are every second.
Much more aggressive.
Yeah,
right.
Absolutely.
But in the upgrade scenario, it's even smarter, isn't it?
Correct. It will seamlessly redirect the IOs because we know the controller virtual machine is going down.
Proactively rather than reactively.
Yeah. Exactly. Now, as soon as this comes back up, all the IOs again will go to the local virtual machine, and then we move on to the next one, and we upgrade that one and reboot it, and then we reboot that one.
And this transitory phase where you've got multiple firmwares in use, multiple versions in use, is going to be fairly brief because it's just literal reboot of each machine. That's not that we're dropping down the image one after another.
No, it's just a restart of the controller virtual machine that sits on the underlying platform. Now, one of the benefits of this is that it could be any hypervisor. It doesn't matter. It's the same code, the same updates apply. It could be different types of hardware under the covers. It could be something that's got lots of compute and not a lot of storage. It could be a lot of storage and not a lot of compute. All of the hardware is completely abstracted by the software-defined storage layer. And the virtual machines, the actual productive virtual machines, don't know that this is happening at all. Now, one of the things that's really neat about this, we don't ever have to reboot the host during this process, but we update the firmware on the hardware components at the same time as we're doing the code upgrade without rebooting the host. So the disks, they all get upgraded to the latest stable firmware version. The IPMI controller will get upgraded to the latest stable firmware version, things like that. Basically, the whole platform's built to be upgraded in place non-disruptively without any impact to the virtual machines or the data or anything like that.
Doing the firmware like that's pretty cool.
It is pretty cool because normally, you can upgrade the storage maybe non-disruptively. In some cases, maybe not. It depends on the array. Yep. But in a lot of cases, the BIOS and the firmware and everything of the host has to be done during a change window.
It's an evening and a weekend gone.
Exactly. You've got to restart the entire host. So one of the smart things that we've done in our software is enable that to happen non-disruptively. Cool. Now, if one of the hosts fails, for example. Now, this is outside of the upgrade process, okay? So we've done the upgrade now. Upgrade's completed. It's all gone through. It's completely non-disruptive. Say somebody's pulled the network cables out or something,
I usually talk about a cleaner with a chainsaw.
Cleaner with a chainsaw, yeah, it's a good one. Anyway, a host's gone down for some reason. So that means the controller virtual machines are gone down. The virtual machines that are running on that host has also gone down. The host is no longer available at all.
It's an X-host.
It's an X-host. Now, I'll go into how difficult that is to actually happen in a moment. But, it can happen. Things fail. We expect that. What happens is normal VMware HA kicks in, and those virtual machines will just be restarted on the other hosts. The data is already throughout the cluster because the data is replicated throughout the cluster for data protection. So the virtual machines will restart, and then the data will, again, be local to those virtual machines. Now, once the data is re-protected, so it comes up to the, policy level of compliance, whichever set for the particular, virtual machine or container that's on, then, and the environment's completely protected again, we can lose another host, and the same process keeps going. So we're not restricted to only losing one host. We can lose many hosts. Now, by default, there's 2 replicas of every piece of data at the block level.
So specifically, that's copy A and copy B.
Correct.
And I've had some people think that 2 replicas meant there were 3 copies, but it's 2 copies.
2 copies, yep, by default. And they're distributed throughout the cluster so that we don't get any hotspots. And it also means rebuild processes can
use every spindle.
Every spindle and very quick. It means that we can survive multiple failures. Now, we have an option in 4.0 where you can actually have 3 copies. So you can survive 2 simultaneous failures of 2 different nodes. But we take the resiliency even further than that because this will be in a single 2U box, potentially.
And if the chainsaw goes through that box?
If the chainsaw goes through that box, provided you have enough boxes, we know where the nodes are in those boxes, and we'll make sure that the replicas are outside of the boundary of an individual box, so you can basically lose an entire box and it will just keep on going. That's what we call our availability domains.
But again, that
feature.
requires 3 of the thing that you're losing as a minimum, so you'd need 3 of these blocks.
Correct.
As a minimum to be able to cope with one catastrophically failing.
Yep.
And of course, you still need enough capacity on the surviving blocks
to
re-protect all
That's
of your
right.
data.
Yep. So it basically becomes a capacity planning exercise. There isn't any storage systems really that you'd run over 90% utilised. So the larger the environment goes, the more efficient it can get, the more failures it can survive, the more resilient it becomes. To take advantage of what we call RF3 or FT2, which is the 3 replicas, you need a minimum of 5 hosts. To take advantage of the availability domains, you need a minimum of 3 blocks. But you can have 5 hosts split across 3 blocks, and that meets that requirement. Or you could have 2 hosts per block, and that also meets that requirement. And maybe you've got those in separate racks. Now, if we look at what it actually takes to lose a host, so I'll draw our standard. So we've got 4 nodes in a 2U box, and we've also got another option where we've got 2 nodes in a 2U box, and we've still got another option, we've got 1 node in a 2U box. Now, with these models, my squares aren't very square, but that's okay. The only thing that's shared, this doesn't really count because that's only 1 node, is the power supplies. So all of the network cables that come out of these are completely independent.
So there's no network switches inside these at all.
No, there's not. Now the reason for that is with the top of rack switching, you can have completely resilient switching, and then we're not basically relying on the chassis itself at that point. The power is shared, but in your rack you will have 2 completely independent power feeds, A feed and B feed.
I hope so.
You hope so, absolutely.
Better test that.
Yep. Yeah, absolutely better test that. I have seen situations where racks have gone down because
I talked to people last week who had exactly that.
Yep.
They thought they had A and B, but some devices were both on A.
Yes, so that's not a good scenario. So assuming that you have independent power feeds, you basically have to lose your entire rack for this to go down, for each of the nodes to go down. Now, of course, there can be drive failures. That's accepted. Drives fail. The system is built to, be resilient against drive failures. Now, one of the unique features of it, because we're only replicating the data that's actually written, we only have to reprotect the data that has been written to that disk. So if you have a single drive failure with a 4 terabyte disk, we can recover that in about 28 minutes. And with the SSDs, the 400 gig or 800 gig SSDs can be recovered incredibly quickly. Yes, that's correct. And the networking, for this to be unavailable, you'd have to lose both your top of rack switches. Again, the top of rack switches should also have A and B power feeds going into them. So from a hardware perspective, it's very unlikely that you're going to lose multiple components.
Yeah, losing a single node is probably going to be operator error.
Yes.
Somebody pulls the wrong node out when they're working on it, or somebody...
Or they restart it through the management cables.
The wrong way,
yep. Or somebody completely disables the VLANs that are used by the top rack switches, for example. So it's much more likely to be a configuration or operator error than it is going to be hardware failure of these particular components. And then, of course, when they scale out and you've got multiple blocks, you'd have to lose an entire block. Now, even if you lost an entire block, assuming nobody has put a chainsaw physically through it, the data's still there. All the disks are still there. Everything's still there. So the absolute worst case scenario is everything goes down. That's if you lose power to multiple racks. But as soon as everything comes back up again, it's just like any other, HA event.
Unplanned failure.
Unplanned failure. Everything's going to restart, and your data's still going to be there.
Yeah, that's one of the interesting things that I like about the platform. And for disclosure, I've taught the training course about this a bit. One of the things we did was go beyond the planned level of failure in one of the labs and turned off more nodes than the platform could support.
Yep.
And the interesting concept was that when the cluster couldn't guarantee availability of data or couldn't guarantee to protect it, it would actually deny access. You would lose the entire data store under it so that you didn't corrupt the data store under it. And having come from a pharmaceutical background, absolutely agree with that one. If you cannot protect the data, you shouldn't present it. in order to not corrupt it.
Data protection is the absolute highest priority above all else. So protecting the data, making sure the data is safe, comes above everything else.
Yeah,
Next
then
thing
is availability.
Next thing's availability, and then maybe performance is after that. Yep, but data protection is definitely the highest priority. And we're absolutely paranoid about protecting data, and that's why we make sure we can recover from failures incredibly quickly with the least amount of disruption, because again, all of the nodes that are in this entire cluster participate in the recovery operation, so they happen very quickly. And that we can get back to a protected state very quickly, and then we can sustain multiple failures as well. Now, if we lose a node, we're only losing a proportion of our access, which is...
You lose some capacity.
Some capacity and some performance, which is a lot better than some traditional storage arrays where you basically lose 50% of your performance straight away, overnight.
Yeah, unless you've aggressively short-stroked, as some arrays do, to protect performance under failure, but then you're degrading performance in normal operation to achieve that.
That's right. So if you run your array at only 50% utilized for performance, then that's fine. You can sustain a single controller failure and keep going at 100%. Yep. Or you can just have a platform that scales out and has lots of controllers, so that the impact of losing a controller is less. But also the impact of virtual machines going crazy on a single host is a lot less as well.
All right, well, thank you, Michael. We've been looking at upgrades and failure scenarios on a Nutanix platform. Nutanix, Michael is a Nutanix engineer. What's your job role with Nutanix?
My role is a senior solutions and performance engineer. So I'm part of the global R&D team for Nutanix, and I'm based out of New Zealand.
Great. Well, thank you for explaining a few things, and particularly some of the new things that are in version 4 of the Nutanix OS. And let the good people at home know where they can find out more about you.
So they can find me at longwhiteclouds.com, which is my blog, and online on Twitter at VCDXNZ001.
This has been Notes for Engineers. I'm Alistair Cook, and you can find us at notesforengineers.com.